So welcome to Radon 101. I'll write it in nice big red letters to emphasize the importance of what we're doing. My name is Tom Schmidt, and I'm your professor for this crash course. I will show you that I have some of my notes on a clipboard. Notice the nice white paper here. This is brand new work that we've done to put together enough information for you to understand why radon matters. And the contrast for me is when I was in business school, we had a professor, Professor Wilson, and he taught us a class called Quantitative Methods, and his notes were yellow and they were brown at the bottom. So he had been doing this for years and years and reading exactly the same information over and over. But we're coming to you today with more and new information that will help you to understand better why radon matters and why you should think about having a device to share that information with your family and with others. Radon is an invisible gas that threatens your home and your family if it's there. By the time I do shut up about this, you'll know enough about radon to let you make an informed decision about whether you should measure it in your house or the buildings you're responsible for. We'll talk about radon's atomic structure, its decay process, the health physics, measurement science, and what mitigation techniques are best supported by EPA data. It's okay if you don't know anything already about radon because we're happy if you're just curious enough to spend some time with us to understand this better. So radon forms from uranium decay in the Earth's crust and has been with us present since the planet cooled about 4.5 million years ago. So let's decode why it matters. First things first, what is radon? Well, many people seem to think that radon comes from some industrial processes, but radon is a naturally occurring radioactive gas. It's there whether or not we put it there or not. It forms underground as part of a slow natural decay process. Specifically, radon comes from uranium, which exists in larger or smaller amounts in soil and rock almost everywhere on Earth. As uranium breaks down, it turns into other elements, and one of those elements is radon. You probably remember from high school chemistry that the gases move pretty freely. Because radon is a gas, it can move freely through soil and rock, and that's how it can eventually reach the surface and enter your house and other buildings that you're responsible for. So it's important that you know something from high school chemistry. If you remember high school chemistry, radon has the symbol Rn, and it has the atomic number 86. Radon is a noble gas, and noble is a great word because noble means of royalty. So these are gases that have a special status in the periodic table of elements. Another noble gas is helium. Helium has an atomic number of 1, which means it has 1 proton. I bring this up because I want to contrast helium with a gas that's just right next to it on the periodic table of elements, which is hydrogen. I'm going to tell you that radon is very stable chemically, which means it doesn't combine with other chemicals quite readily. Helium and hydrogen have very, very similar chemical properties and very, very similar physical properties. They're both lighter than air. Helium is a noble gas. Hydrogen is not a noble gas. If you remember in the 1930s, there was this great big, wonderful dirigible called the Hindenburg. The Hindenburg was filled with hydrogen. At the same time, they also filled these dirigibles with helium, but this was filled with hydrogen. It was struck by lightning. It blew up. When something is very unstable, when it chemically reacts very easily and with high energy, it can be very dangerous. Hydrogen is very dangerous because it's chemically unstable. Helium, which is a noble gas, is very stable. If we fill a dirigible and strike it with lightning, nothing will happen. Radon is much more similar to helium than it is to hydrogen, which means that it's very difficult for us to do some mitigation by taking it out of the air using some chemical process because it simply does not react. And that makes it a dangerous thing because it accumulates and accumulates and accumulates. If you think about your basement, it's quite possible that your basement is wet. You take a desiccant, something that pulls water out of the air. You can't do that with radon. That's one of the things that makes it very dangerous is that it accumulates. So let's review. Radon is not man-made. It's not pollution in the traditional sense. It's not caused by modern industry, and radon has been here as long as the Earth has existed. So why should we care, though? The reason we care today about it is simple. We spend most of our lives indoors, which means that when we're sitting watching our screens of all kinds of various sorts, we are quite possibly being exposed to increasing levels of radon because the radon is trapped within our houses. So the first question is, how does radon get into our houses or into our buildings? Well, remember that the radon is constantly released from the ground below us. Outdoors, it usually disperses quite readily. It doesn't reach harmful levels. And indoors, though, the situation is quite different. Buildings can create a pressure difference between the inside and the outside that pulls air inside and pulls radon inside, which means that it can accumulate. Let's take a look quickly at how radon can get into the house. We have a jar that shows exactly how radon can get into the house. It can seep up through these stones, and you can see there's lots of space between these stones, right? And then using our Aeronet Radon Plus, we can see the level of radon. And if you look at the front of this thing, you would see that the radon levels are pretty high. So it gets up through here, it accumulates when we're trapping it, and then we have very high radon levels. So if we seal our house tightly, this is really good for heat retention. It means that in very cold places, of course, we hold in the heat, we pay less for heating, but it allows radon to accumulate even more. And then the question arises, how do we measure radon? Well, it's a great question. Radon is measured by monitoring the amount of radioactive decay that happens in the air. And there are two main units that are used globally. The first unit is becquerels per cubic meter, which is in most countries the way radon is measured. So becquerels per cubic meters, and for those of us who are keeping track at home in the United States, a cubic yard, which we're most used to, is about 30% bigger than a cubic meter. So just for your background. So 1 becquerel means 1 instance of radioactive decay per second. So a level of 100 becquerels per cubic meter means that in every cubic meter of air, 100 radioactive decays are happening every second. Sounds like a lot to me. This unit comes from the International System of Units and directly reflects physical radioactive activity. The other unit that's used, and which is most commonly used in the United States, is picocuries per liter. In the United States, radon is measured in these picocuries per liter, or picocuries per liter. So what is a pico? It's not even close to this lovely flute-like instrument, the piccolo. When I did cardiology research, we dealt in picomolar concentrations, and I know that pico concentration is really small. Pico means 10 to the minus 12. That's a decimal followed by 11 zeros. So a picocurie is 0.000000000001. This unit honors the legacy of the great physicist Marie Curie and historically described the radioactivity of radium. Although the units are different between becquerels and picocuries, they do measure the same thing. For your reference, 4 picocuries per liter is approximately equal to 148 becquerels per cubic meter. So why do radon levels vary so much? Well, radon levels do vary quite dramatically, even between neighboring houses, between neighboring buildings. That's because radon depends on the local geology, soil permeability. So you have sandy soil, loamy soil, peaty soil, whatever, the foundation type you have, the ventilation of your house, the weather and the seasons. Radon levels often do rise during the winter, and you think about that makes sense because you close all your windows, you seal up the vent from your bathroom, so you're very well sealed, which means that you should be looking at those changes, especially in the winter, on a daily basis. Understanding radon levels, so what's good, what's acceptable, and when should you act? Once you start measuring radon, the next question is simple. What do these numbers actually mean? First, an important caveat. There is no completely safe level of radon. So because radon is radioactive, even low levels can carry some risk. That said, health organizations have established action levels to help people to understand when they can make practical decisions about taking mitigation steps, even if they're as simple as opening windows. Low radon levels are generally good, of course. So radon levels below 100 becquerels per cubic meter, or roughly below 2.7 picocuries per liter, are generally considered low. At these kind of low levels, the risk is relatively small. And other than probably opening a window, maybe, you really don't need to do much to do mitigation. But it's still recommended that you do continuous monitoring or continuing monitoring. But radon levels do change over time, so you should not ignore these low levels. You should continue to measure. Now, what about moderate levels? Well, that's acceptable, but not ideal. Radon levels between 100 and 300 becquerels per cubic meter, or approximately 2.7 to 8 picocuries per liter, are considered moderate. So low, moderate, we're getting there. In this range, risk is higher than ideal. Mitigation can be recommended by experts, and long-term monitoring becomes especially important. Sometimes simple improvements like better ventilation can already reduce levels significantly. But remember, what that means is that you have to have your device, one of these lovely devices, you have to have them in your basement so you can continue to measure what is changing based on your mitigation tools. So what about high radon levels? That's kind of the scariest level. So we're way up here. When we're talking about higher levels, action is recommended. We're talking about radon levels above 300 becquerels per cubic meter or 4 picocuries per liter in the United States. These are widely recommended as levels where action is strongly recommended. These thresholds are based on decades of research linking radon exposure to lung cancer risk. The higher the level and the longer the exposure, the greater the risk of lung cancer in people, especially in people who don't smoke. Why do long-term measurements matter? Well, radon levels are not static. And when you understand that, you understand that you can find changes with seasons, with specific weather, with your ventilation habits, with air pressure in your house and the differences in there. And short-term tests can show spikes, whereas long-term measurement shows your true average exposure, which is what health risk is based on. When it comes to radon trends, do matter more than just the snapshots. So if you think about the snapshots of your parents versus how you've seen them change over the years or your children, that shows that same set of changes that you do want to pay attention. So radon itself isn't the biggest problem. It's what happens after it decays. As radon breaks down, it produces radioactive byproducts. And these particles are the things that get into your lungs. They attach to dust and aerosols, are inhaled into your lungs. They adhere into your lungs, and then they are the things that start to degrade your DNA. They're the things that start to degrade your cells, and that is what leads to damaged cells and cancer. So over time, the damage increases, and you have a higher risk of lung cancer. Radon is the second leading cause of lung cancer overall, and the leading cause of lung cancer among non-smokers. So for Americans, you might know of a comedian. His name is Andy Kaufman. And Andy Kaufman died of lung cancer, but he never smoked. And people were astonished by that fact. And I actually remember when he died in the mid-'80s, people being surprised. And at that point, we started also discussing radon a little bit more because people wondered if his large oat cell cancer was caused by radon exposure where he came from in the eastern part of the United States, where there are high levels of radon. So you need this testing because testing allows you to understand your exposure, identify patterns of that exposure, and then make informed decisions. Radon data turns an unknown risk into something measurable, and you can take action based on reliable data. So what are the tools that you can use for radon mitigation, and what does it mean? Radon mitigation doesn't remove radon. Remember, we talked about how it's very chemically stable. What it does, it prevents radon from entering or accumulating inside of your living space. And you do that by things like sealing cracks and openings where the radon can get into your house through things like sump pump pipes and then drains. You can improve ventilation. You can install active radiation mitigation systems. One of the most effective methods is called subslab depressurization, which redirects radon safely outside before it enters the building. The options for mitigations are quite varied. They depend from state to state or country to country. So do your own investigations, talk to experts in this area, and find one that fits your budgets and your needs best. So that's why continuous measurement matters. Devices like AirNet Radon Plus and AirNet Radon 1 are designed to do exactly that, to measure radon levels over time rather than giving you a single snapshot. Both of them continuously track radon concentration, helping you to understand long-term averages, which drive your decision making. Spot seasonal patterns, notice sudden changes, which can cause you to do something very drastic and quickly, and then see how ventilation or mitigation changes that you make affect your home or the buildings you're responsible for. AirNet Radon Plus is ideal for those who want detailed insights and continuous monitoring with clear data that can be used to evaluate long-term exposure. AirNet Radon 1 focuses on simplicity. It makes measuring radon accessible, clear, and easy to understand at a glance. Both tools turn an invisible risk into something measurable and actionable. Once you know your levels, you can decide what action to take with confidence, not guesswork. I hope at the end of this time that we've spent together, that you've learned something about radon in general. You have good arguments to make about why you should measure radon, measure it not just once, but over time, looking for averages, and then how you can mitigate, and then how you can continue to measure to make sure that your mitigation does what you want it to do. I wish you the best of luck in making these decisions for yourself, your family, and for those who rely on you.